Hi, everybody. Welcome to Lesson 11 here, where we're going to be talking about the special role that zero plays when we factor. So let's start off here by looking at each of these equations and listing some values of x and y. So I need two numbers here, x and y, that when I have their product gives me 10. So I'm thinking, I don't know, 2 and 5, 1 and 10, -2 and -5. But I can also get creative, like 4 and 2.5. 3 and 10/3. There's a lot of numbers that I can find their product and end up getting 10. The same thing with 1. 1 times 1 gives me 1. 1 times -1 gives me 1. But again, I can get creative. 2 times a half. 4 times a fourth. 7 times 1/7. So there's a lot of ways to get 1 when I multiply things together. Same thing for -1. This is the exact same thing, except someone's got to be negative. Sorry, that should have been both negative there. My fault. I was looking over here. -2 and -1/2 and +1/2. -2 and +1/2. 3 and -1/3. There's lots of ways that I can get a product to be -1. But over here, something interesting is going to happen. If I have 5 times what gives me 0? Well, 5 times 0 is 0. 2 times 0 is 0. 10 times 0 is 0. 7/4 times 0 is 0. The key thing here is if I have a product equaling 0, one of the factors had to have been 0. I can't tell you about the factors over here, but when things equal 0, one of the factors has to be 0. So this is called the zero product property. It says if a product equals 0, if a product equals 0, then at least one of the factors, at least one factor equals 0. So in symbols, if a times b equals 0, then one of the factors, a is 0 or b is 0. So if I find the product of two things and get 0, one of those things had to have been 0. So if I have star times smiley face times heart times chicken nugget equals 0, this tells me if star times smiley face times heart times chicken nugget equals 0, this then tells me the zero product property, the hashtag ZPP, put that on your Instagram post, hashtag ZPP. This tells me that one of my factors here, either the star is 0, or the smiley face is 0, or the heart is 0, or the chicken nugget is 0. So the zero product property says if I multiply a bunch of stuff together and get 0, one of those factors has had to have been 0. So find the solutions. How does this relate to polynomials? Well, this is going to connect us from factoring to solving. So find all solutions to this equation here. So I have the equation x squared plus 5x plus 6 times x squared minus 3x minus 4 equals 0. Well, I can factor these more. So let's factor these more. This is a trinomial, so what multiplies to 6 and adds to 5? Those two factors are x plus 2 and x plus 3. And this is also a trinomial, what multiplies to -4 that adds to -3, x minus 4x plus 1. So now I have 4 factors being multiplied together and equal 0. So the zero product property tells me this factor is 0, x plus 2 equals 0, this factor is 0, that factor is 0, or that factor is 0. And we can quickly solve all of these. How do I get x by itself? I subtract 2. What plus 3 is 0? X equals -3. What minus 4 is 0? X equals 4. And x plus 1 is 0, so x equals -1. So the key steps to solving these equations when I have polynomials involved, the first step is make sure it's equal 0. That's the first thing. It has to equal 0. Then you're going to do some kind of factoring technique. And then the third step is actually apply the zero product property. Apply the ZPP. And we call it the zero product property because it has to be equal to 0 and it has to be written as a product. It has to be in factored form for us to actually apply this property. Most of you can probably skip that middle step there and jump right to here. So what makes x plus 2 0? Well, negative 2 plus 2 is 0. Let's try another one. Find all solutions to this equation. So we've got some factoring to do here. So let's look at this first factor. It's set equal to 0, so we're good. Now let's do some factoring. It looks like perfect cubes, but it's not because there's a GCF that has to come out. All right, so I took out a GCF, and oh, that's the difference of perfect squares. X plus 3x minus 3. X times x is x squared. 3 times 3 is 9. Over here, I've got 4 terms, so this is telling me it's a grouping problem. So let's do some grouping. Look at my first 2 terms, take out your GCF. Your back 2 terms somehow need to become x plus 1. So I'll take out a negative 1. So I get x plus 1 is my new GCF, and I'm left with x squared minus 1. But then, of course, this is the difference of perfect squares, so I can factor this guy into x plus 1, x minus 1. Whew. You got to be quick at factoring, folks, or you can pause the video and rewatch it to catch up to where I am. But right now, I have x times x plus 3 times x minus 3 times x plus 1 times x plus 1 times x minus 1 equals 0. The zero product property says if I multiply a bunch of things together and get 0, one of these things here has to be 0. So people always panic at this one. If you have a plain old x here, if you have a plain old x sitting there, x equals 0 is a solution. X equals negative 3. X equals positive 3. Notice it's the opposite. It's the opposite value. X equals negative 1. X equals negative 1 again. And x equals 1. These here are my solutions. Sometimes our solutions repeat, and we're going to talk about the effect of that when I have a repeated solution like I do here with the negative 1 and the negative 1. But those are my solutions. Those are what make this equation equal to 0. Sorry for the yawn there. Sorry for the yawn. All right, let's slide on through. So page 3, number 3, we're going to skip here. We're actually going to jump right to number 4 here, where I want you guys to solve some for me on your own. So take a second, pause the video right now, and see if you can factor this left-hand side of the equation. All right, so I'm going to factor out x squared, left with 2x plus 1. So I better end up with 2x plus 1 over here. Notice it is equal to 0, so that's good. Take out a negative 9, good. So 2x plus 1 times x squared minus 9. But of course, I'm always looking out for difference of squares. So 2x plus 1, x plus 3, x minus 3 equals 0. This product equals 0, so we can apply the 0 product property. X equals negative 3, x equals 3. And then for this one, I've got to do a little bit of work. I got to subtract over the 1. And then there's that extra step of dividing by 2. So it's x equals negative 1/2. So make sure when you have that coefficient in front of x, you notice it's just not the opposite. It's the opposite divided by that coefficient. So I like to just go through the steps there and solve for x that way. All right, let's slide on over here. And I'm going to pause the video and ask you to tell me what's wrong with this equation from the start. If I look at it, I have a big problem of why I can't use the 0 product property. So the big problem is it's not equal to 0. So we've got to make it equal to 0 by subtracting over that 6. So step 1 is always making sure it actually equals 0. And now I get to apply some kind of factoring technique. And for this one, I've got to use the AC method. So I'm figuring out what multiplies to negative 24, a times c, that adds to positive 5. And I got 8 and negative 3, right? 8 times negative 3, 8 plus negative 3, good. So that forces me to split the middleman. This isn't a quick trinomial. This is a trinomial where you got to split the middle term there and turn it into grouping. So now I group. I need an x plus 2 over here. So I'll take out a negative 3. And then that leaves me with x plus 2 times 4x minus 3 equals 0, because it's an equation. I'm not just factoring an expression. I'm actually solving an equation this time. So the product of two things makes 0. X has to equal negative 2, because negative 2 plus 2 is 0. Or 4x minus 3 equals 0. Add the 3 over, divide by 4. X equals negative 3/4. Those are my two solutions. Those are the two values that when I plug it in, make it equal 0. So let's look at this one here, if it loads ever. State the zeros of this function. State the zeros of this function here. Well, it's kind of factored, but right now I see a 3, okay? That's the difference of perfect squares. Can't touch that guy. Can't touch that thing. And then this is a trinomial, but it's an easy trinomial at least, because I've got x in the front seat. What multiplies to 4 and adds to 4? I'm thinking plus 2 and plus 2. 2 plus 2 is 4. 2 times 2 is 4. So if I want to find the zeros, I set it equal to 0. 3 doesn't give me any zeros. 3 is just a number, so he's useless. This is called the leading coefficient. The leading coefficient there is useless. It affects the graph of these polynomials, but it doesn't actually affect the zeros. So I get x equals negative 2. I get x equals 2. X equals negative 3. X equals 2. X equals negative 2. X equals negative 2. So I have some repeated roots here. What this tells me is that I have some repeated roots. These are repeated zeros. Or you could say I have repeated factors, right? I have repeated zeros because I also have repeated factors. Those are also repeated there. So we give that repetition there a name, and it's called the multiplicity. So I can say x equals negative 2 has a multiplicity of, well, how many of them are there? 1, 2, 3 has a multiplicity of 3. X equals 2 has a multiplicity of, well, how many x equals 2s are there? There's 2 of them. X equals negative 3 has a multiplicity of 1. There's only one of them. And again, you normally don't have to write this because it's going to affect the graph. This whole multiplicity thing is key for when we graph them. But I just want you to know that vocabulary word. You don't need to write that out unless I explicitly say what are the multiplicities or why is this happening. Then you can talk about multiplicity. But just know that word is a repeated zero. It's a repeated factor giving me that 0 multiple times. So find a polynomial function that has the following zeros and multiplicities. So what is the degree of your polynomial? So x equals 2 is a 0. So what factor, so for my polynomial, what factor gives me a 0 at x equals 2? How did I get a 0 at x equals 2? I had a factor of, not negative 2, factors are binomials, x minus 2. And how many of them do I want to have? I want to have 3 of them. So I'm going to cube it. If I want a 0 at negative 4, what factor gives me negative 4? X plus 4. And I only want one of them. If I have a 0 at 6, I have x minus 6 as a factor because there's that opposite relationship between my zeros and factors. And I happen to have 6 of them. And I have a 0 at negative 8, so x plus 8. And I have 10 of those parentheses. Instead of writing it out 10 times, I'm just going to put that exponent there. So it says, what is the degree of the polynomial? Well, the degree, remember, is the highest power. The highest power in standard form. In standard form. So if I was to make boxes and multiply this all out, what would my highest exponent will be? Well, how many factors do I have? How many factors do I have? I have 1, 2, 3, 4, 6 more, and then 10. So I have 10 plus 6 plus 1 plus 3. That's how many factors I have. I have 20 factors. I have 20 factors, so x to the 20th will be the first term. Because I have those 20 factors, x to the 20th, so the degree is 20. The degree there is 20. And is this the only polynomial I can make? Well, the answer is no, because remember I said how that leading coefficient can kind of just show up. That 3 doesn't change the zeros at all. It doesn't change the degree. It's just a number that's multiplying and stretching my graph. I can put a -1 there. There's a lot of different numbers that can fill this leading coefficient space. I can put any non-zero number there. And I can't put 0 there because hopefully that makes sense that if I put 0 there, it's just going to wipe everybody out and make them 0. Any non-zero number can be our leading coefficient. Our leading coefficient. And when we start graphing these polynomials, this idea of degree, leading coefficient, and zeros are going to have a huge effect on our graphs. So to review this lesson, we can solve a polynomial equation by setting things equal to 0 and factoring. And once we factor, we can apply the zero product property to actually get our zeros. And I'll see you guys in the next lesson.